Should you use Terraform Workspaces, and when are they appropriate? That is what we're going to get into in this episode of Terraform Tuesday. What's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to another Terraform Tuesday. Today, I want to talk about a comment that I made in a previous video. I'd been talking about the new -or create flag that exists in the Terraform Workspace select command. It was introduced in 1.4. Now, as part of that video, I made an offhanded comment about how HashiCorp no longer recommends using open source workspaces for production environments and how I had some opinions about that. I got a bunch of comments asking me to elaborate on those opinions, so I thought I'd dig more into it in this video. Before I get into that, I do want to thank today's sponsor, M0. More about them a little bit later. Now, this is going to be more of a long-form discussion than a typical how-to video. So if you're interested in just how to use Terraform Workspaces, you might want to check out a previous video on the topic or just look up the documentation. But if you're interested in the why behind the what, then watch on. I first discovered Terraform Workspaces way back in like 0.9 when they were still called environments. And I thought they were the bee's knees. But as I've used Terraform more and more, I've come to realize that there are some serious potential problems with the open source version of Terraform Workspaces, and I'm not the only one. HashiCorp has updated their guidance on the use of Terraform Workspaces, essentially saying that they're good enough for development and temporary environments, but they're really not intended for production usage. Well, why not? And what should you do instead? Let's dig more into that, and we're going to start with the problem. We really have to get back to first principles. What is the problem Terraform Workspaces are trying to solve? The main challenge that they're trying to support is multiple environments that are using the same basic body of code. So for an example, I might have a development environment, a staging environment, and a production environment, and I want to use the same Terraform configuration for all three. Each environment is going to have some elements of commonality, but also some differences. They're not all going to be completely identical. For example, the production environment is probably going to be the most robust. It's going to have more and bigger servers, enhanced security, some lockdown permissions, a full-scale firewall, more performance storage, and production-grade databases. You get the idea. Now, that would obviously be overkill for a development environment, where things are going to be scaled down to a more reasonable level, since the goal of a development environment is usually to test functionality and not the performance. Your staging environment might be a mix of the two, with some production level elements as needed and some development level elements, because maybe your staging environment doesn't need to be as robust as production. Now, I need to manage and maintain all of these different infrastructure environments, and they're very similar in nature, but they're not exact copies. Now, layer on top of that, I probably want to reuse my code as much as possible and minimize the administrative overhead of managing all these environments. I might want to use Terraform and infrastructure as code to do that. Now, I also have to maintain a separation of concerns and access between the various environments. My developers probably shouldn't have access to production information and shouldn't be able to deploy updates to prod without going through a change process. Now, whether that's an actual code promotion process or just a manual copy of the code from one environment to another, I need to be able to control permissions and access to those various environments. So that's the problem space that we're dealing with. Let's talk about some possible solutions. Based on the problem space, Terraform Workspaces are one way to deal with the problem. However, we're going to run into issues pretty quickly. Now, other possible solutions could include using something like environments that exist in GitHub Actions, or a similar feature in other similar tools. You could maintain each environment in a separate directory of the same repository. So have a directory for dev, staging, and prod. You could use separate branches for each environment in your source code repository and have promotion rules and permissions between the various branches. Something has to go through devs and staging before it can be merged into the prod branch. Or you could have a separate repository for each environment and copy the changes between them. I'm not going to go through each of these solutions in detail because the focus is on Terraform Workspaces. Now, if you'd like to hear more about one of those approaches, let me know. I can certainly do a follow-up video on each of them. Just let me know down in the comments. Now, what are the problems with Terraform Workspaces if that's the solution you've chosen? To best understand the problem with Terraform Workspaces, it's important to first understand how they actually work under the covers. When you create a Terraform workspace, you are essentially creating a new instance of state data. Each workspace is going to be using the same configuration files, the same providers and modules, including the versions of those providers and modules, and the same state data back end. The differentiation between environments is going to be from maybe the values that you use for the input variables and how they're interpreted by the configuration. You also have access to the workspace name from within the configuration by using the terraform.workspace value. You can use that to add conditionality for resource creation. You can control naming or select sizing and other parameters based on the environment or workspace you're currently in. In fact, you could have all your values for each environment stored in a web accessible data source and access the data source with the workspace name as an argument to get the appropriate values for that environment. That's certainly an approach that I've seen. Now, whether you choose to use variable value files, the TF-var files per workspace, or you source your values down from a data source, or you inject them at runtime from your CI/CD pipeline software, the end result is basically the same, and it doesn't really matter for our purposes. The issues with Terraform Workspaces come from three things: the shared code base, the shared state, and the shared providers and modules. Having a shared code base across your environments is a good thing, right? That's the point of workspaces. It reduces the amount of code you have to maintain. But problems arise when you want to make a change to the code base and test it before rolling it out to upper environments. Now, how would you make such a change? Well, if you're not using source control, first of all, that's weird. You should probably change that. And second of all, any changes you make to your code will be equally applied to all workspaces. Let's walk through an example. Let's say I've got three environments, again, dev, staging, and prod, and they're each using a Terraform workspace and leveraging the same code. When I want to make a change, I update the code, I switch to the dev workspace, and I run a Terraform plan. Assuming things look good, I apply the change to the dev workspace. Then I switch to the staging workspace, run a plan and apply, and then finally do the same for prod. Now, this workflow actually is great if it's just me. But if I'm trying to work in a team, changes that were made and being tested in dev may accidentally be applied to the staging or prod environments if I'm not careful and I don't communicate with the rest of my team. Now, the typical way around this is to either duplicate the code base for each environment and put it in its own directory, or create a separate branch for each environment. If you've created a directory for each environment in your repository, then you don't actually need workspaces because you're no longer sharing code. Likewise, if you have a separate branch for each environment, you also no longer need to use workspaces because you're no longer using the same exact directory for each environment. You're using the code in that particular branch and commit. In either case, you no longer need to use Terraform Workspaces. For the directory situation, I can tell which environment I'm in from the path.cwd value, which gives you the current working directory. And in the branch situation, I can simply inject the branch name as part of the Terraform run. Both of those solutions don't require the use of Terraform Workspaces, and it also frees you up to store your state data in a separate location for each environment, which might be a good thing. Aside from having a shared codebase and having to be careful around promoting issues, the second big problem with workspaces is that all the workspaces associated with a Terraform configuration will share the same state backend. That's not necessarily a problem, but it does mean that each environment must have read-write access to its state data. And it probably is going to get access to all the other workspaces' state data unless you do some serious granular permissions. And your backend of choice needs to support those permissions. Let's take a look at how the state data is stored on a backend like Azure Storage, let's say. Each workspace in Azure Storage backend uses the same storage account and the same blob container, which you can think of a blob container as a directory. It's really just a prefix path, but think of it as a directory, right? When you initialize Terraform, you'll pass it the storage account information, including the container name and the key to use for the blobs. The default workspace will use the key value alone. So if my key value is app.a.tfstate, the blob that goes into the container will be called app.a.tfstate. As I create additional workspaces, each will get the same blob name, that app.a.tfstate, but it's going to append env : and the workspace name. So if I have a workspace named dev, then the blob name is going to be app.a.tfstate env : dev. Now each workspace has its own state blob, but they're all sharing the same Azure storage account and blob container. With the exception of using shared access signature tokens, also known as SAS tokens, the lowest level you can set permissions on Azure Storage is at the container level, meaning that any client who has access to update one workspace will also have access to view and modify all the other workspaces, including production. And since there tends to be sensitive information in the state data, that's a problem. Could you use SAS tokens? Yes, you can use SAS tokens. However, provisioning SAS tokens itself is kind of a pain outside of particular automation scenarios. You know what's way easier? Just using a separate storage account or container for each environment. Then you can set the permissions there. Now, maybe you have a storage account that is dedicated to holding the state data for production workloads, and you have it locked down 3 ways from Sunday. You can only get to it from certain networks and all kinds of other permissions. Now, if that's the case, and you want to have a separate storage account for each environment, you can't use Terraform Workspaces because it doesn't support it. And that's just if you happen to be using the Azure Storage backend. I'm sure the other backend options are also fraught with similar permissions issues. The shared state backend of workspaces is a big security risk, and Terraform open source workspaces doesn't really have a permissions model to handle it. Hence why there's a lot of solutions that enhance what Terraform open source can do.
Amazing segue.
Today's sponsor is M0. You know, in this video, I'm talking a lot about the shortcomings of Terraform open source workspaces and alternative solutions for managing your infrastructure as code deployment and workflow. M0 is a managed service that works with Terraform, TerraGrunt, AWS CloudFormation, and even Kubernetes, providing centralized infrastructure as code management, IAC security and permissions control, GitOps integrated workflows, and the ability to bring your own integrations through their extensible pipeline model. Now, I took M0 for a test drive last year, and I was personally impressed by their support for mature IAC management workflows, and especially their tight integration with source control through things like pull requests, comments, and commits. Another thing I really liked was a TTL for temporary environments, so you don't accidentally leave resources running and eat up your precious cloud funds. If you like to take them for a spin, they have a generous free tier and you can sign up at m0.com. That's env0.com. Thanks to M0 for sponsoring my ridiculous ramblings. Now back to the video.
You made it.
The third issue is regarding shared providers and modules, which is very similar to the shared code. Now, there's nothing inherently wrong with the shared providers and modules across the workspaces. In fact, you probably should be using the same providers and modules across all of your environments. But you might not want to use the same versions of each module and provider right away. And that's not a choice you can make with workspaces. For starters, they have a common .terraform.lock HCL file. And the version constraints for the providers and modules you're using are part of the configuration itself. So we're back to the same issue we had as the shared codebase. If a new version of the AWS provider is released, and I want to test it out in dev before promoting it to staging and prod, I have to be very careful with my workspaces. Now, to upgrade in the first place, I would need to change my version constraints in the configuration and then run Terraform init with the -upgrade flag to update the lock file. That change is going to impact all workspaces, and it might not be nearly as obvious as other code changes. So if someone else on my team is rolling out a change and they don't realize that I updated the version constraints, they could end up using the newer version of that module or provider in production and cause issues or even downtime. If you happen to get bit by the upgrade from AWS v3 to v4, you know what I'm talking about. The solution, as before, is to instead split the environments either into separate directories or separate source code branches. And again, in either case, you no longer need to use Terraform Workspaces to provide that separation. It's now being provided through another functionality. Given all this information regarding Terraform Workspaces, are they bad? I know I started the whole video with the catchy title of Workspaces are bad, actually. And you know what? For long-lived environments where you plan to promote code changes and need strict separation of concerns, Terraform OpenSpace Workspaces are a bad solution. They just don't fit the requirements that are defined by the problem. Now, when would you use workspaces? Well, they are great for temporary environments where you want to do some quick testing with your code without impacting the long-lived environment. So maybe I'm trying something new with the code locally and I don't want to blow up the shared dev environment. I can create a temporary workspace, execute my changes there, and if things look good, I can destroy that workspace and then push the change to source control and then let my usual CI/CD process take over to promote that change to the development environment. Or maybe I'm trying to test out a new module or provider version and I don't want to impact the other environments. I can create a workspace and test it out there. When I'm done, I destroy the workspace and promote the change to the other environments. That could be especially useful when you're leveraging something like TerraTest, let's say. You can create a workspace through TerraTest, spin up that temporary environment, run the tests you've defined, and then destroy the environment when you're done, along with the workspace. I should also say that this is specific to Terraform open source environments and not Terraform Cloud Workspaces. Terraform Cloud Workspaces deal with many of these issues by rolling out workspace level permissions, variable values per workspace, and tracking separate branches of a VCS repo for each workspace. While the two types of workspaces seem similar, they are in fact quite different in practice. To sum it all up, Terraform open source workspaces are good for temporary environments, but they fall short in many ways when it comes to managing long-lived environments. And that's especially true if you're collaborating on a team or you need separation of permissions for each environment and a well-defined code promotion process. There are a ton of other solutions out there that help you deal with these separate long-lived environments while still using the same essential code base. It's just that Terraform open source workspaces aren't the right solution. Now, that's my opinion, but I'd love to hear your thoughts on this. Do you use Terraform Workspaces today? Do you have any other solutions that you use to manage long-lived environments? Let me know in the comments below. Thanks everybody for watching today. If you liked this video, please take a moment and subscribe. I certainly appreciate it. Or just like the video. That's pretty good too. I'll be back next time. Until then, stay healthy, stay safe out there. Bye for now. You probably can't see it, but I'm wearing my new HashiCorp Ambassador 2023 shirt. I'm so excited to have another one. If you didn't catch it, I posted a picture of all the different Ambassador shirts I've had since the program began. I think this is my favorite. They keep outdoing themselves every year. All right, bye.